Hello, this is Eduardo Suarez. In this video, I'm going to show you how to control the general speed override using a KAREL program. We're going to start with the work cell I have already created. If we go to Robot Controller, Properties, you can see that I have already installed the option package KAREL R632. We're going to start by running this main program. We're going to go to Simulations and Start. As you can see, it's a very simple pick and place application between two tables. And on the top right, we have the general speed override indication. As you already know, we can use the jog plus and the jog minus keys to change the speed. We can go down, we can go up, and also we can use the shift plus the jog minus and jog plus key to change the speed. Also, there are a few other options for controlling the speed externally. One of the options is the override select. This is a built-in application that already exists in the teach pendant. If we go to Menu, Setup, Override Select, here we have the application. As you can see, this function is already disabled, and it gives us two digital inputs that we can use for controlling the speed. You can select in here and change the digital input if you want. And underneath, we have a truth table with the 4 possible status of the two inputs. And on the right, we have an option to select the speed, the override speed that we want to use for each one of these options. I'm going to open in here the digital inputs. We're going to go to Menu, Inputs, Digital. We're going to select Inputs, and as you can see, I already selected the digital input 1 and 2 as a simulation. And if we change the status of this digital input, let's say we take a digital input 2 and we change it to on, you're going to see that the status of the digital input 2 is reflected on the override select screen. Same if we select the digital input 1. So we're going to run the simulation again, and this time we're going to enable this function, and we're going to control the speed using these two digital inputs. Now, if we want to change, for example, we are running at 100% because we have the digital input 1 and digital input 2 off. That corresponds to the line number 5 of the truth table, where we have a 100% override. Now if we select digital input 2 on, we're going to change that to 50% override, as you can see here. And we can go to 10% override if we select digital input 1 on and digital input 2 off. And finally, if we select both digital input on, we're going to go back to 1%. Let's talk about the advantages and disadvantages of using this override select. Advantage is going to be that this is a built-in application that already exists on the teach pendant, and it's very simple to use. The disadvantages is that is using only 2 digital inputs. You cannot go over, for example, using robot inputs. It's only restricted to digital inputs. And you have only 2 options in here. So if you want to have more granularity on the speed control, this is going to give you only 4 possible options. We're going to disable this option for now, and we're going to look at the other option that we can use for controlling the speed override. We can create a macro and run it as a background logic. If you go to select, I have already created a speed override program. If we go to details, you're going to see that in the group mask, I have already disabled the motion group number 1. And now, if we go to menu, setup, background logic, I have already selected the speed override on the line number 1. If this line is empty, you just go to choose and select the program that you want to run as a background logic. And then you can change the status from stopped to run. We're going to see for a moment how the macro looks like. We're going to open this program, and you can see here that it has an if instruction that is looking at the status of the teach pendant enable. If the teach pendant enable is disabled, is off, what I'm going to do, I'm going to assign the value from register number 3 to the general speed override. And if the teach pendant is enabled, this logic is not going to work. That would be the case, for example, when we want to jog the robot manually. In that case, we just enable the teach pendant, and we use the jog plus and jog minus key. We're going to go back to select. We're going to select our main program, and we're going to run the simulation again. In this case, we're going to look at the register number 3. And you can see here that I have selected register number 3 as a speed control, and it has a ready value of 10. That is overriding the speed indication, as you can see here. We can change that value. We can go to 90%. We can go to 100%, and the speed is going to change accordingly. We're going to stop the simulation for now. We are going to go back to the background logic, and we're going to disable that. And now we're going to look at how can create a KAREL program that do something similar to what we have seen so far. Before we create our KAREL program, I want to show you something. Let's go to Tools. We're going to go back to the folder for the work cell. We're going to go to the folder for Robo1, and you can see here that is missing a folder that is going to be created the moment that we build our first KAREL program. We're going to come back to this one later. For now, we're going to create the KAREL program. We go to Files. We're going to create new file, and we're going to create a KAREL program. For now, we are not going to do anything. Just we're going to keep this folder, this file blank, and we're just going to build it. Obviously, this is going to give us an error because there is no logic in there. But if we go back to Tools, we go to the folder for the work cell. Now we go to the folder for Robo 1. You're going to see that there is a new folder support that it was created automatically the moment that we build our first KAREL program. And in here is going to create automatically a bunch of KAREL program or KAREL files that we can use later. We're going to save our new KAREL program. We're going to call it speed control. We're going to insert our first version of the program. We're going to call it speed control version 1. First, I want to give you a little trick in here. Notice that you're not going to find any zoom in and zoom out buttons on the menu bar. So if you want to change the size of the text, you need to press the Ctrl key and move the wheel in the mouse. Also notice that the name of the file is speed control, and the name of the KAREL program is speed control version 1. Just a reminder that the name of the file is not related to the name of the KAREL program. This file is just a container for the KAREL program and is used only to reference the build command. Once the program is built, it will be converted to a P-code file. The name will be speed control version 1 with extension PC. At the beginning of the program, we have two translator directives. All the translator directives start with a percentage character and must be placed right after the program statement. With the only exception of the include translator directive, we're going to see the include translator directive later in our version of the speed control program. The first translator directive comment is just for adding a comment or description to the program, and the second translator directive, NOLOCKGROUP, works in the same way as the macro, meaning that is not taking control of any motion group. On the declaration section, I have defined a routine called main with a statement from main. This is another way of calling a program. And on the executable section, I have an infinite loop with a repeat until statement that is going to terminate when digital input 3 is on, and we are calling repeatedly the main routine. We're going to save this program. We're going to build it, and we're going to run it. So we're going to go to programs, and we're going to create a simulation program. We're going to call it speed control simulation. And what we're going to do is just call our KAREL program. We're going to open the teach pendant. And we're going to run the simulation. Notice that it works exactly the same as it was working before when we call the main program on the teach pendant. Now we can still control the speed override using the jog plus and minus buttons, also the shift plus and minus. And if we want to use the menu setup override select, if we enable the override select and we select the inputs, we can just change the speed to 50%, 10%, and 1% as per the through table on the override select. So now we are going to disable this function and we're going to update our KAREL program to do something similar to this override select. We're going to stop the simulation and we're going to take this program, we're going to delete it, and we're going to copy the new version of the speed control program, and we're going to introduce the concept of condition handler. We're going to pause for a moment here to talk about the condition handler statement so you can understand how the program works. The condition handler statement does not exist in the TP program. It's a unique statement for the KAREL programming. These statements allow specific conditions to be monitored in parallel with the normal execution of the program. And if the conditions occur, actions can be taken in response. There can be up to 1,000 condition handler statements started with index 1. And the condition handler needs to be defined and then enabled for the condition to be monitored. We're going to define the condition handler in the execution section of the KAREL program using the condition statement followed by the index in bracket and followed by the colon. These index numbers are unique. That means that once you have defined one condition handler, you cannot define the same condition handler again unless you have purged with a purge statement. The conditions to be monitored are specified with the when clause, as we have in this case. And KAREL is very restrictive in the conditions that you can use. One of the conditions that you can monitor are ports ID. Ports ID are basically predefined digital ports such as digital input and digital outputs, OP input, OP outputs, robot inputs, robot outputs, and TP inputs and TP outputs. Multiple conditions must all be separated by that AND statement, as we're using in this case, or an OR operator. Mixing AND operators and OR operators is not allowed. Whenever a condition handler is triggered, it is automatically disabled unless an enabled action is included in the action list. You can use enable, disable, and purge conditions. That means that anytime during the program execution, you can control the condition handlers. The condition handlers are global. That means that once they are defined and enabled, the condition is monitored in parallel with the execution of any program, as we're going to see in our example. Now, talking about the conditions can be any of the following two types, either states or events. States are conditions that remain satisfied as long as the state exists. For example, these are the state conditions because the digital inputs are going to remain either on or off while the condition is monitored. On the other hand, events are conditions that are satisfied only as at the instance of the event occurred. For example, when we want to detect a rising edge of a falling edge of a digital input. After the conditions, there are actions list. These are the actions that are going to be taken if the conditions are satisfied. Here we have our action list for the condition handler number 1. Actions are specified inside the when clause. Actions are also very limited in the KAREL statements or operations. We can do assignments as shown in this example. Assigning a constant value to the system variable general speed override. We can do monitor related actions, motion related actions such as stop, resume, cancel, hold, and unhold. Both of these actions, assignments and motions actions, are executed in parallel with the program. Also, as part of the actions, we can call routine. In this case, the routine will interrupt the execution of the program. When we use a routine call in the action list, there are also restrictions. The routine cannot have any parameters, and the routine can only be a procedure, not a function. Just to clarify, the difference between a procedure and a function routine is that a function will return a value. So basically, that's I cover all that we need to know about the condition handlers to be used in this program. This version of the KAREL program, we're going to use only the state conditions and assignments in the action list. In a second version, we're going to cover the event conditions and the routines called in the action list. In this version of the program, I have defined 4 condition handlers to replicate the 4 state combinations that we have for the 2 digital inputs on the truth table of the override select screen. Condition handler 1 is on monitor the condition for digital input 1 off and digital input 2 off. These are the state combinations because we want to trigger the condition handlers when both inputs are off. We can use an even condition here because it would be very unlikely that both input 1 and input 2 change status at the same time. This condition is going to cover the condition that we have in line number 5 of the through table. In this case, because we want to have a speed override of 100%, I'm going to assign 100 to the system variable general override. Also, as part of the action list, I'm going to enable all the other condition handlers. Condition handler 2 is very similar. Here, we're going to monitor digital input 1 off and digital input 2 on. That's going to give us 50% speed override. That's why we're going to assign 50 to the system variable general override. Now, following the same idea, we're going to define condition handler 3 and 4. After the definition, we need to enable all the condition handlers before we can call the main program so the conditions can start to be monitored. I want to point out the fact that in this KAREL program, we have more flexibility than in the override select built-in function. For example, we can use 3 digital inputs instead of just 2. And in that case, the truth table will give us 8 different state combinations of the digital inputs, so we can have more granularity in the speed control if we want. Also, we can change the digital inputs for robot inputs of any other predefined port IDs, as we're going to see in the second version of this program. We're going to save this program. We're going to build that again, and we're going to run the simulation. I'm going to bring up the teach pendant, and you can see here that the override select is disabled, so the speed control is done by our KAREL program. Now we're running a 100% override. I can change digital input 2 to on, and condition handler 2 is going to be a trigger. That's why we change the speed to 50%. I can disable that. We go back to 100%. In this case, condition handler 1 was triggered. Now we can go to 10%. And finally, we can go to 1%. And we can go back to any other the other speed combination if we want. In that case, we can see that the KAREL program is working as expected. We're going to stop the simulation now, and we're going to go back to our KAREL program. We have succeeded in replicating the override select function using a KAREL program. Now we're going to create a second version. We're going to add more condition handlers, but this time we're going to use event condition instead of state conditions, and we're going to call routines inside the action list. We're going to delete this program and create a new program. We're going to call it Speed Control version 2. I'm going to add this program to the description below so you can have access to that. In this version of the program, I have defined 4 more condition handlers. Each one is calling a routine in the action list. We're going to start by looking at the new translator directive that I have added. It's called include. As I've already mentioned before, this is the only translator directive that can be placed in other parts of the program, not necessarily after the program statement. Notice that this translator directive has a file name after the statement, and what it's going to do is going to add this file to the KAREL program at the moment that is translated. If you go to Tools, we go to the folder for the work cell. We're going to go to Robot 1. We're going to go to Support. You're going to find that this file is there, and we can open this file using the Notepad++. You're going to see at the top of the file there is a constant instruction, and after that there is a big list of variables. Each one has a number assigned to it. In particular, we are looking for this one in here. Each one of the numbers represents the code number for each one of the keys in the teach pendant. In particular, we are looking for the user tool number 1 and user tool number 2 keys, and the shift plus the user tool 1 and shift plus user tool 2. In a moment, I'm going to show you how we're going to use this in the program. For now, we can close this one, and we're going to go back to our KAREL program. Also, I can show you here how we can replace, instead of using this include plus the file name, we can replace that with just adding the constants, the declaration for the variables in the declaration section of the program. Would be something like adding these instructions in there. We're going to review now what the new condition handlers are doing. The condition handlers are number 5, 6, 7, and 8. If we look at condition handler number 5, it's going to monitor the teach pendant key for the user tool 1. The instruction that we're going to use is port ID EP in, and in brackets we add the code number for the user tool 1 key that in this case we're going to replace with the variable name that was defined in the file that was included in the translator directive. So it has a more meaningful name than just the code number for the teach pendant key. In this case, we're not looking at the status, we're looking at the event when the key is pressed. If we want to monitor the event instead of the state, we add a plus or minus sign after the port ID. In this case, the plus sign means we are going to monitor the rising edge of the port ID. If we use a minus sign, we are going to monitor the falling edge of the port ID. The action list is just a call to a routine. Similarly, we have condition handler number 6, 7, and 8 that are going to monitor the event for the teach pendant key user tool 2, shift plus user tool 1, and shift plus user tool 2. Now, if we look at the routines, condition handler number 5 is calling the routine speed up. In this case, we have an if statement. If the system variable is in the range from 5 to 100%, we're going to increase the speed by 5%. Otherwise, we're going to increase the speed only by 1%. After the if statement, we enable the condition 105 again. Otherwise, it's going to remain disabled and it's not going to be able to increase the speed again. The other three routines follow the same idea. Condition handler number 6 is calling the speed down. This routine is going to decrease the speed by 5% or 1%, depending on the range of the general override. And if we press the Shift plus the user tool 1 or user tool 2 keys, we're going to change the speed by a set number of 100%, 50%, and 5%. If we're going up and if we're going down, it's going to be 1%, 5%, and 50%. We're going to save this program. We're going to build it. And we're going to call the simulation program. We're going to change the name to Speed Control version 2. And we're going to run the simulation. We're going to bring the teach pendant. And you can see now, if we use the jog speed down, we're going to decrease the speed by 5% at a time. We can increase it by 5% at a time. But also we can use the user tools. We're going to use the user tool 2 and decrease by 5% or increase by 5% using the user tool 1. Also, if we are below the 5%, we are decreasing by 1% or we're increasing just by 1%. The same way, we can use the Shift key and increase the speed to 50% and 100%, or decrease the speed to 50%, 5%, and 1%. So we can see that our KAREL program works in the same way as using the jog speed. We're going to stop the simulation and we're going to go back to our KAREL program. Last but not least, we're going to delete this program and create a new version. We're going to call it Speed Control version 3. This time we're going to simplify the logic. We're going to have only one condition handler that is going to monitor the teach pendant enable. The port ID for the teach pendant is OP out and the code number is 23. Condition handler 1 is going to be triggered only when the teach pendant is disabled. In that case, the action list is going to be a call to a routine that I call it speed select. If we look at the definition of the routine, what this is doing is reading the value of the register 3. The instruction is get register, and the parameters is the register number, that in our case is 3, is real, is going to be number 1 or 0, depending if the register is a real or an integer. The integer value, if the register is an integer, or the real value, if the register is a real. And finally, the status is going to be 0 or 1, depending if the read instruction succeeded or failed. In our case, we're going to use an integer value, and we're going to assign the value to the system variable general override. We're going to save this program. We're going to build it. We're going to call the simulation program. We're going to change it to speed control version 3, and we're going to run it. We're going to bring the teach pendant, and we're going to open the registers. You can see in the case we have a register 3, has a value 100. If we change this value, the general override goes to the value that we selected. We can open the background logic, and we can see here that the macro that we were using before is stop. That means that we are controlling the general override speed entirely from our KAREL program. To wrap up this video, I gave you a quick introduction to condition handlers. There are many restrictions on how condition handlers can be used. In our case, we use state conditions and event conditions to trigger the condition handlers. And for the action list, we used assignments and routine calls. What is interesting about condition handlers is that they only exist in KAREL programming, are global, and can be used in any moment during the execution of our programs. Finally, I gave you 3 examples on how we can use condition handlers to control the general override speed in the same way you do using the teach pendant and the functions available in TP programming.